Hey, very good evening. Very good evening, all my dear students. Welcome, vanakkam, suswagatam. Jo bole Sonyal, Sastrikal, Walaikum Salam, Assalamu Alaikum. All my dear students, just to let me know, am I audible as well as visible to all of you or not? Just to let me know in the chat section. I want to see green hearts, green lips, kids. Today I'm going to tell you the most important thing. But just before that, I want to see your attendance by smashing the like button. Kids, button is just in front of you. Everyone, let me check it out whether everyone can hear me, can see me or not. I want to see the Deepavali in the chat section, colorful chat section. I want to see kids. Your Baba HSP is over here right now, welcoming you all, my dear students. Yes, everyone. Let me see how many of you are there, kids. Let me check it out. Let me see who is over here. Bhavani, welcome. Priyaji, Mandy, Sahana, warm welcome. Call everyone, wherever they are. And if I'm perfectly audible, I would like to see that your chat should be full of green hearts, indicating that yes, perfectly audible as well as visible, kids. Oh, yeah, call everyone. Chaitanya is missing. Why Chaitanya is not there? Priya, I'm good, I'm good. Chaitanya is there. Wow, Chaitanya, yes. Oh, 1 hour, not more than that. So let's it go, kids. Let's it go. I think everything is perfect. Everything is perfect. Now, my dear friends, I would like to see what is written over here. Parent carbon is not the necessary condition for a compound to be optically active. Oh my God, what is this? In your school, you must have studied that chiral carbon is the necessary condition for a compound to be optically active. Am I right or wrong, kids? And I'm saying that chiral carbon, who is saying? Baba HSP is saying. These are the words written by Baba HSP. According to Baba HSP, is saying that chiral carbon is not the necessary condition for a compound to be optically active. Then what is the necessary condition? And sir, what are you talking about? Just prove it that this is wrong. My dear students, in the chat section, do let me know how many of you want to see that I am going to prove that this is wrong, whatever you have studied till now. How many of you want to know? See, what is chiral carbon? First of all, I will tell you chiral carbon. Then I will tell you anything else. Okay, ready? Fine. Nalla Riku. Chiral carbon. Everyone, take a note. What is being chiral carbon? This chiral carbon is also known as asymmetric carbon. Asymmetric carbon. Now, who is chiral carbon? Who is asymmetric carbon? Let's see. Carbon attached to four different atoms or groups according to CIP rule. According to CIP rule, is your chiral carbon. That is your chiral carbon. It's, mark my words, this is going to be a chiral carbon. For example, if I say that a carbon attached with fluorine, bromine, iodine, then this carbon is going to be a chiral carbon. Now, my dear students, I would like to tell you one thing, that why in your school, whatever the questions you were solving, and you are getting full marks. Remember one thing, that if a compound is having one chiral carbon, remember that if a compound is having just one chiral carbon, compound is having just one chiral carbon. What I'm saying, kids? What I'm saying? If a compound is having only one chiral carbon, then it will always be optically active, and that's why in your school you are always getting full marks. Note, make a note, if a compound is having only one chiral carbon, then the compound will always be optically active. Now kids, some of you might got confused. So in the starting, you have shown that slide where it was written that chiral carbon is not the necessary condition for a compound to be optically active. Now you also started talking about chiral carbon. So then why you told this thing that chiral carbon is not the necessary condition for a compound to be optically active? Why you're saying like this? Now, how many of you really want to go to the upper level of vision? What I'm trying to tell you, what I'm going to explain about it, how I'm going to tell you the truth. So I want to see some fire in the chat section. If you really want to understand, kids, I want to see some fire in the chat section. Then only I'm going to reveal the truth. Then only I'm going to tell you the truth, that what actually I want to prove. That is going to change your level. It's going to change your vision of thinking, kids. Everyone, I want to see some fire in the chat section. And then I will give you a question, lot of questions, number of questions. You are going to get, kids, number of questions. Ready? Okay, let's come to this point. Necessary condition for a compound to be optically active. What is the necessary condition? Let's see. Oh, what is this? Necessary condition. One and only one necessary condition. That the compound must be chiral. Compound must be chiral. Now, so what is this? I know what is chiral carbon, and you are writing compound must be chiral. What is the meaning of this? Compound must be chiral. Now, for a compound to be chiral, compound shouldn't contain any symmetry. Now, what type of symmetry? So what do you mean by symmetry? Axis of symmetry? No, kids, not axis of symmetry. Should not contain cos and cos. These two things should not be there. Then whether the chiral carbon is there or chiral carbon is not there, compound will be 100% optically active. What I'm saying, kids, if cos and cos is not there, then the compound will always be optically active. Now, what is this pos and cos? Let me tell you, pos means and cos means. Pos means plane of symmetry, and cos means center of symmetry. Now, how many of you really want to visualize plane of symmetry and center of symmetry? Once again, show me some fire in the chat section, kids. In between you and me, the only medium is this chat section. I want to see everything in the chat. Then only I can tell you all those things, and then only I can ask the questions. Kids, fast, fast, fast. Now, first, plane of symmetry. What is plane of symmetry, kids? An imaginary plane which divides the whole compound in two equal parts. Two equal parts. Two equal parts. I will tell you right now. Two equal parts. So that one part is the exact mirror image of second part. Now, how to visualize it? This is going to change your life. If you're able to understand this thing, definitely you can understand anything, kids. Let me draw that. Suppose if I say, if I write down A, if I draw A, now tell me from where should I bisect it so that you can get the plane of symmetry. See, this portion, if I draw it like this portion is dividing the whole compound in two equal parts. Can you see? So this is vertical plane of symmetry, vertical. Pause. So this compound can't be optically active. Can't be optically active. Are you getting my point? It cannot be optically active. Now if I draw B, so if I divide it from here, this is known as horizontal plane of symmetry. Can you see, kids? Try to get familiar with the terms. Whatever I'm telling you, this is known as horizontal plane of symmetry. Now, these compounds I'm drawing, it's okay, but now let's come to the original compound so that we can understand. We can understand each and everything. Are you ready, kids? Are you ready, kids? The actual compound you want to understand, do let me know in the chat section. Yes, you are ready. Now see, if I say that carbon attached, one carbon is attached with X, Y, M and N, four different atoms. One carbon is attached with A2, B2. One carbon is attached with A2, BX. Now remember that this is not having any plane of symmetry. No cos, no cos. Right now I will tell you no cos. Cos I will tell you later on. But no cos and cos, this compound. So this compound is optically active. But this A2B2, A2BX, they are having plane of symmetry. They are having plane of symmetry. So definitely such type of compound can't be optically active. Can't be optically active. For example, if I write, CH2 Cl2, or if I write CH2 ClBr, they can't be optically active. But if I write CH chlorine, bromine, 1, 2, 3, 4, one random monunale, all four are different. All four are different. So I have told you in the starting only, if the compound is having one chiral carbon, then compound is always optically active. So this is chiral carbon and the compound is chiral. Compound is chiral. What do you mean by this? If compound is having just one chiral carbon, then the compound will also be chiral because it will never have phosphorus. Now, how many of you really want to visualize this? If you really want to visualize this, show me green hearts in the chat section so I will manage to visualize it. Yes. How many of you want? I want to see green hearts in the chat section if you really want to visualize it. Fast, fast, kids, fast. So see, if I say I'm having this one atom, my hand is being carbon and this is being first atom. And if I say this is being second atom, two atoms I have got. Now if I say this is the third atom, this is third atom, and let me say this is the fourth atom. This is the fourth atom. Now you see, if all four are different, if all four are being different, just say, can you see, kids? Can you see? Can you see? The tetrahedral valency 2V, 2V. First try to see 2 V's. Can you see? Let me make it. Okay, give me some time. Let me bring some pen. Okay, just give me some time. Kids, I got it. I got it. Now see, always whenever you try to see the 3D diagram of tetrahedral, see this is 90 degree and now it is 109 degree. Can you see? Two different pens. These are the atoms. Suppose this is chlorine, this is bromine. And if I say this is your hydrogen and this is your iodine, right? Four different. Can you see, kids? First of all, do let me know. Can you see? Is it visible, kids? Tetrahedral. Always write down if it is visible, kids. I want to see your answer. Is it visible, kids? Everyone. Now see, if you try to bisect it, if you try like this blue pen, half of the pen will go to right hand side and half of the pen will go to the left hand side. And here, this half of the pen will go right hand side and half of the pen will go left hand side. But see, this side is different and this side is different. These two halves, they are not the mirror image because the left hand side right? This red and this is different. Now, if you try to bisect like this will get bisected half of same side, but this side is blue and this side is gray. So if carbon is attached with two different atoms or groups, it will never have plane of symmetry. And this is your chiral carbon. Got it, kids? Everyone, Sahana, I can see Sahana has got it. Rest of other students, do let me know. Yes, yes, write down yes, yes, if you got it. Now, so I have written that this compound, which is attached with four different groups, X, Y, Mn, A, B, C, D, whatever, will always be optically active because there is no pause, no cause, and they will have. Now, see, if I change it, this is black, and in place of red, if I say this is also black, now see, this is also black. Now, try to see it. Try to bisect it. If I'm bisecting it, half of the red will go on the right hand side and half of the red will go on left hand side. And then I'm going to bisect this side also black and this side also black. So if two valencies are same, then it will always have plane of symmetry. I hope this is clear. Is this clear to each and every one of you? So if a compound is having only one chiral carbon, then that compound will always be optically active. Now, let's see how many of you got it. Find out. Question is, I'm going to give you question. Find out total number of chiral carbons in the following. CH3, CHOH, CH, Cl, CH, CH3, CH double bond CH2. What's your answer? I'm waiting for answer, kids. Tell me. Number of chiral carbons in the following compound. Let me sit in front of screen and check it out. Thank you, friends, forever. Everyone just do let me know the answer. What's your answer? Fast, quick, quick, kids, quick. I want to see the answer, my dear friends. Your Baba is waiting. Question number 1 लिख देते हैं बिल्कुल प्रिया जी आपका सूक्ष्म सर आंखों पर. Question number 1. सुन रहा है दीवाना दीवाना ला 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 तुमसे मिलके ला 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 ला. Sahara's answer is correct. This carbon is chiral. This carbon is chiral and this carbon is chiral. See, this carbon is attached with methyl OH and this long chain. This carbon is attached with hydrogen, chlorine. This side different. That answer is 3. Answer is 3. Everyone got it? Got it or not? Have you got it? Everyone? Now, second question. Once again, total number of chiral carbons. Yes. Yes, kids. Let me see and let me sit in front of screen and let me check it out. What's your answer, kids? Fast. Be fast. Hey, everyone. Arey, very good, Priyaji. That's really awesome. Awesome blossom. If you're liking this session, everyone call your friends, kids, and smash the like button. If you're really liking it, if you're really enjoying it, kids, I want to see your appreciation. Abhinandan Mukherjee, Medico, everyone. If you're really liking it, Chaitanya Mashkare is going for 4. Abhinandan is going for 5. Sahana is also going for 5. Let me check it out. What your Baba HSP is going to say, kids. Let's see. This is Chiral. 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 1, 2, 3, 4, 5. One and a monunale. Anche. Answer is 5. Now 5. Now another one. Let's see. Now, my dear students, do you know what is this? This is your D glucose. Now I want to ask how many chiral carbons? Total number of chiral carbons. Your question is number of chiral carbons. Let me sit in front of screen and let me check it out, my dear students. What's your answer? I'm waiting for your answer, kids. Everyone. Medico is going for 4. 4. Sahana, Priya, question number 3. That's really awesome. This is question number 3. Priyaji, thank you. And there are 4 chiral carbons. 1, Turan, Mon, Nal, 4. 1, 2, 3, 4. 4 chiral carbons. Now, my dear students, if somebody is asking Paranose ring structure of glucose. Paranose ring structure of glucose. Paranose ring structure of glucose. Now, this will be having how many chiral carbons? Let's see, kids. Paranose ring structure of glucose. Tell me. Total number of chiral carbons in this compound. Paranose ring structure of glucose. I'm waiting for your answer. So let's see who is going to give the correct answer. 1, 6. Fifth ring. Second. Third. Fourth. This is your, you know very well, the one who is able to understand chemistry or biology. They can understand this is alpha D positive glucose. Paranose ring structure of glucose. So many times they have asked this question in the examination. Let me check it out. How many of you can do this question? Let me see how many are. Yeah, Sahana, that's really awesome. Chaitanya Maskre, wow. That's so nice of kids. You kids are really rocking, kids. You made my day. Baba is feeling accomplished, kids. 5. Swami, very good. In previous question, it's not 5. See, why not 5 in previous question? This is attached with double bond, so it can't be. can't be, and this is attached with two hydrogens, so it can't be. Got it? These two can't be. Somebody is attached with double or triple bond, can't be chiral. Attached to double bond or triple bond, can't be chiral. Can't be chiral. Got it? So this is not chiral and this is also not chiral. Now see, here, how many are chiral and which are they? This one is also chiral. This is known as anomeric carbon, if you know, kids. Anomeric carbon. This is chiral, this is chiral, this is chiral, this is chiral. Five are chiral. Now, why I have started with chiral carbon, and you must be waiting, sir, how chiral carbon is not the necessary condition. That point I will come. But right now, why I'm dealing with total number of chiral carbons. So let's see how to find out total number of optically active. So let me write down total number of optically active compounds. Total number of optically active compounds. What is it? It's written. Let me rub it. What happened? Total number of optical isomers is equal to total number of optically active isomers. Now, will you say this is valid everywhere? No, kids. This is valid only when there is no what? No plane of symmetry in any of the representation of compound. What I'm saying, kids, this is valid. So I will say this is valid for case number one. What is case number one? When no structural representation is having cos. That means if I say this is me, this is a compound, treat me as a compound. I'm standing like this, there is no plane of symmetry. If I'm standing like this, no plane of symmetry. If I'm standing like this, no plane of symmetry. But if I stand like this, or if I stand like this, then I can be divided in two equal parts. Don't count the internal organs. Or if I stand like this, I can be divided in two equal parts. So I'm not the case one. Case one means when a compound is not having any symmetry, that means right hand side is different, left side is having something different. Let me say in my right hand there is red pen and left hand there is green pen. Now if I'm standing like this, if I'm standing like this, if I'm standing like this, no one can divide me in two equal parts because the extreme right hand side and extreme left hand side is totally different. You got it? Who is the case number one? Everyone got it. So case number one, when no structural representation is having cos. No pos and cos is there, then total number of optical isomers will be equal to total number of optically active isomers. So that we write down total number of optical isomers shortcut and total number of optically active isomers. And what should be the formula? The formula will be that TNOI is equal to TNOAI is equal to 2 raised to power n and where n is equal to number of chiral carbons. Now, if you are able to understand this formula, then I will give you a question. Tell me in the chat section that you got it, got this formula, then you are ready for the questions. Now see question number 1, then question number 5. Find out total number of optically active isomers for beta D glucose. Beta D glucose. Now I would like to see the answer in the chat section. Who's going to give me the correct answer? Yes. I'm waiting for your answer over here. Let's see, kids. Gona ready? Dr. Pinmin Bhai is here. Chatra has good evening, good evening. So everyone do let me know what's your answer. Fast, fast, quick, 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 kids. Sahara is going with 32. 32, yeah. So I got the correct answer. Chaitanya and Sahana has given the absolutely correct answer. So 5 chiral carbons. So the value 5 chiral carbons, that means the value of n has come out to be 5. So total number of optically active isomers 2 raised to power 5. That is 2 into 2 into 2 into 2 into 2. 2 twos are 4, 2s are 8, 2s are 16, 2s are 32. Just like our teeth, 2, 1, 2, 3, or like peristomial teeth, trifida, tetrafida, rixia, markensia, peristomial teeth, right? 32 in number, right? Now you got it. Now another question. Question number 6. Find out total number of optically active isomers in Furano's ring structure of hemiketal fructose. Do you know fructose, my dear students? Fructose. So let me give you options also. 32, 16, 8, 4. Let me see. Let me sit in front of screen, kids. And everyone hit the like button, kids. Baba needs your likes, kids. And call your friends. Everyone, if you're really liking this session. If you're really enjoying this session, kids. 16. People are going for 16. That's really awesome. I can understand that good students are over here. Really intelligent students are watching this lecture. 16 is the correct answer. So let me draw its Furano structure. So I would like to say it's H2OH, the anomeric carbon 1, 2, 3, 4, 5, 6. It's CH2OH. The ring is being formed over here. So it's H, third carbon H, OH, H, OH and H. This is your structure, and I can say these two are opposite, so they are alpha. Alpha. Now, this is chiral carbon 1, 2, 3, and 4. There are 4 chiral carbons to 2 raised to power 4. That is coming out 16. I hope that everyone got it. Everyone. Clear? Now, this was the case number 1. Now, if you really want to understand the case number 2, hey, hip hip hooray! Everyone, are you ready for the case number 2? I want to see some fire along with green hearts, kids. Hey, if the Josh is missing, how I'm going to tell you, how I'm going to teach you, kids. Really do let me know that you are really enjoying it. If you're really enjoying this lecture, why don't you call your friends? Why? Let's put all the messages green hearts over there. Now, case number 2, kids. Now I'm so excited, but you people are not looking that much excited, kids. But before I move towards case number 2, let's see the questions based on plane of symmetry. Question based on plane of symmetry. Okay, ready? Question number 6, I think, based on plane of symmetry. Now, if I draw something like this, now tell me this is having plane of symmetry or not? Yes or no? Write down yes or no. Plane of symmetry. Yes or no, kids? Josh is high. Really, that's really awesome. Now tell me, plane of symmetry is there or not? Yes or no, kids? Yes or no? If you really want to become genius, if you really want to go to the government seat of AIMS, any NEET seat or IT seat, now everyone got failed. My dear students, all of you got failed. This is a question for AIMS Delhi. See, if I take this paper, just see if I take this paper, let's say it is cyclobutane. Let's say it is cyclobutane. Just see. It's cyclobutane. Can you see? Now, whatever I'm going to put over here, whatever I'm going to join at this place and something different at this place, diagonally, just see diagonally, okay? And I'm putting something over here and downside. Now cut, diagonally cut. If I'm cutting it diagonally, half of the blue pen will go to right hand side and half of the blue pen will go right hand left hand side. Half of the black pen will go right hand side and half of the black pen will go right this left hand side. And if you come at this place, half of the red will go right hand side, half of the red will go left hand side, and whatever is downward side, that will also go. So there is diagonal plane of symmetry. Can you see, kids? Can you see, kids? Just to let me know, there is diagonal plane of symmetry, and that is over here. Just see, try to understand. If I cut it like this, it will get divided into 2 parts. Can you see, kids? Just to let me know everyone is able to understand. If you're not able to understand, no problem. Tell me, I will explain it 100 times. I will explain it 100 times, but Do let me know that you are able to understand or not. I respect you a lot, so it's my duty to explain it in a better way. You're not able to understand it. But first of all, do let me know that everyone got it. That if you got it, that if I cut like this, one chlorine, this is spherical chlorine, half of the chlorine will go towards this side, half of the chlorine will go that side, half of the chlorine towards right hand side, half of the towards out of the both side, and methyl must be having two hydrogens like this and one hydrogen in the plane, one this side, one back of the board, and chlorine half toward this side, half back of the both side. Can you see kids there is plane of symmetry? Just to let me know in the chat section if everyone got it, kids. Baba is waiting for your answer, waiting for your reply, kids. It's there, plane of symmetry is there. Force is present, so compound is optically inactive. So, are you going to accept the challenge? Should I give you one more question? Should I give you one more question? Let's see. Is it having plane of symmetry? Question number 7. Plane of symmetry is present or absent? Fast, fast. Do let me know in the chat section. Speedily, kids. I want to see the answer. Speedily. So, definitely your answer will be, it's easy. Plane of symmetry is present. This is vertical plane of symmetry. If you divide it from here, there is plane of symmetry. But now, if I draw its transform, tell me kids, if I draw its transform, then do let me know. Chlorine here, chlorine is over here. Now it is having plane of symmetry or not. This was the cis form, and this is its transform. I'm waiting for your answer in the chat. Do let me know, kids. Now, what do you think? Plane of symmetry is there or not in the transform? Fast. Sahana Medico, Priyanka Goswami. Where's the time to la 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 la? Yeah, Pinminba. No, no, no. Now you are acting smart, kids. That's really fantastic. No pause. So compound is optically active. No pause. Compound. Cos is also not there. No cos. Let me explain why no cos. Compound is optically active. Now it's a time to explain about center of symmetry also, because again and again I'm writing no pause, no cos. So people must be thinking, sir, what is cos? So let me explain center of symmetry. Are you ready? Let me try to draw one flower. I don't know how to draw a flower, but I'm trying, kids. Don't laugh, okay? Now kids, if I sit at the center of this compound, I'm a B. And if I go vertically in the opposite direction, anyway, just see if I go vertically opposite, so I'm going up, vertically opposite, I'm going up. Whatever I'm getting, same thing I'm getting vertically opposite at the same distance. If I'm going towards right hand direction, I'm going left hand direction, I'm going here, I'm going here, I'm getting. So I'm getting the same environment in the 360 direction everywhere where I'm going. I'm getting the same thing. Just see vertically opposite at same direction, same place, everything. 360, I'm getting the same thing. That means center of symmetry is there. So center of symmetry is an imaginary center just at the center of the compound. If we go vertically opposite, we'll get the same thing. Now let me draw one compound and tell me how to visualize that. If I write down CO and H and H, now see, if I sit in the center of the compound, if I go vertically opposite, I got CO, I got CO, I got NH, I got NH, I got bond, I got bond, I got bond, I got bond. So vertically opposite at the same distance, I'm getting same thing. That means cos is present. Cos is present. The compound can't be optically active. I hope everyone got it. Everyone got it. Now I will give you one tough question. First of all, do let me know in the chat section that everyone got it or not. Everyone just do let me know. Fast, fast, kids. Be fast. That everyone got it or not, able to understand or not. Okay. So see, now tell me, plane of symmetry is present, center of symmetry is present, which symmetry is present? Do let me know in the chat section. What type of symmetry is in this compound? Everyone. Wow, Mandy, are you new? Thank you, Mandy. Medico, very good. COS is present. If you're really liking this lecture, kids, why don't you call everyone? Now, kids, do let me know. COS is present. Sahana, Everyone do let me know and hit the like button, kids. Smash the like button. Cos is present. What's about plane of symmetry? I'm asking about plane of symmetry. Now see, kids, people are writing cos is present. Now see, yes, of course, why not? Cos is being present. See, if you sit over here and if you go up, you will meet with chlorine, and if you go down, you will meet with chlorine. And if you go here, you will meet with bromine, and if you go there, you will meet with bromine. So cos is present, right? Now, what's about plane of symmetry? If you cut it diagonally, you cut it diagonally, kids. If you cut it diagonally, you will see that plane of symmetry is there. Diagonal plane of symmetry is there. Just see, kids. Diagonal plane of symmetry. Can you see? If you cut it like this, diagonally it will bisect in two equal parts. So diagonal plane of symmetry is also there. So compound is declared to be optically inactive. Compound is optically inactive. I hope everyone got it. Now let's proceed towards, just to let me know that if you got it or not. If yes, I will proceed towards case number 2. Fast, quick, quick. Everyone show me green hearts if you really got it. I want to see green hearts if you really got it, kids. Fast, fast. Now, case number 2. When some representation of compound, or we can say when any representation of compound, when any representation of compound is having cos or cos, and others are not having, and others are not having, then this is case number 2. Then it's total number of optically active isomers plus meso, now new term meso isomers will be equal to total number of optical isomers, and total number of optical isomers is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1. What is p? Now you will ask. I will let you know what is being p. But for that, you have to wait for some time. Total number of isomers will be like this. Leave it. Okay. Now let me explain. Now here, two subcases arises whether the number of chiral carbons are even or the chiral carbons are odd. With after explaining this, the session will get over, right, kids? Now let me tell you what is the value of P and how many cases, subcases are there. So subcase 1, subcase 1, when n is equal to even, then total number of optical, total number of optical isomers is equal to 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to n by 2. And what is n? N is equal to number of chiral carbons. Number of chiral carbons. Okay. So let's talk about the most important compound, that is tartaric acid. Everyone ready? Tartaric acid. Tartaric acid, kids. So kids, are you ready for the tartaric acid? So this session will get over just in 10 to 15 minutes, my dear students, because YT session means you have to understand each and everything, kids. Okay. Now, if I take, for example, tartaric acid. Now, first thing is that you should know what is tartaric acid. So let me explain the same thing on the next page. But see over here, tartaric acid is COOH, CHOH, CHOH, COOH. Can you tell me how many carbons are there? One and one and two carbons. So if I apply the formula, what do you get? 2 raised to power 2 minus 1 plus 2 raised to power p is equal to n by 2. That means 2 by 2 minus 1. So it will come out 2 raised to power 1 plus 2 raised to power 0. 2 raised to power 2 is 2, and anything raised to power 0 is being 1. So 3. Out of these 3, these are optically active. Total number of optically active isomers. And these are meso isomers. Now kids, from this, what can you say? Total number of optically active isomers 2 and meso are 1. So 3 is total. Now, formula is going to increase our speed. Formula is never going to visualize. Formula is never going to teach us anything. How many of you want to see the visualization of it? Do let me know in the chat section. Show me green hearts if you need visualization, proper visualization of this, because formula just increases. Formula is for just increasing the speed. And before I move ahead, kids, let me tell you one thing. You must be in need of such a great thing. See, unset. Do you know unset? Take the ultimate test of talent, ITJ NEET UG class 9 to 12, National Science Exploration at INC. Total scholarship worth rupees 200 crores. My God. Meet and greet with Mr. Sachin. And Mr. Sachin. Neha, Sachin. This is and certificates for city and school toppers. That's really awesome. And you must be thinking of who is Baba HSP. So see, this is your Baba HSP, chemistry group, M.Tech from HVTI Kanpur, then MSc in 99 gold medalist, and 27 is here student, so old one, no? Old slide 20 plus 7, 27 years of teaching experience and produce rank 1 to 17 and number of other ranks. You know, Mehak Arora, Tanishka Yadav, All India first rank, Mehak Arora, AIMS third rank, Chaitanya Mittal, AIMS fourth rank. At that time, AIMS was taking separate examination. Now let's see what kids are writing. Priyaji, wow, Sahana, thank you. Wow, Medico, thank you. Now, kids, are you ready? For that case, is everyone ready, kids? So sub case 1, the visualization part. Let's see and let's visualize the great tartaric acid. because number of exams will ask this question. So see, this is your tartaric acid COOH, CHOH, CHOH, COOH. So let me write down. So sequence. If I write down OH, OH, H, H, COOH, COOH, and if I try to draw the line, and if I try to bisect it from here, now see upside OH, downside H, no plane of symmetry is there. Can you see? We cannot divide this compound in two equal parts. That's not possible at all. So no plane of symmetry is there. No plane of symmetry. Are you getting my point? No cos, no cos, no plane of symmetry, no center of symmetry. So this compound is declared to be optically active. Compound is optically active. Am I right, kids? Am I right? Now, it is having two carbons. This form is optically active. Now, if I place here mirror, what you will see in the mirror? The another compound, it's mirror image. Mirror image will be over there. COOH, OH, H, H, OH, and COOH. So this is also optically active. If I say this is dextro, because we cannot say dextro and levo because they are experimental. So definitely it will be levo. And if I say that is levo, this is dextro. So these two are non-superimposable mirror images of each other. I'm not saying impossible, impossible. Non-superimposable mirror images. Non-impossible mirror images. And one term is there for such type of mirror images. That term is known as that they are enantiomer of each other. Suppose if I say Champa is sister of Alia, then Alia will be sister of Champa. Champa and Alia being the two names, but the relation is that they are sisters. So they are enantiomeric pair. What I'm saying is they are enantiomeric pair. Are you clear with this? Enantiomeric pairs. Now if I draw one more, now see kids. Now can you see the plane of symmetry kids? This is also having two chiral carbons. Can you see something that plane of symmetry is there or not kids? Do let me know. Do let me know. Plane of symmetry is there. This compound can be divided in two equal parts. That you can see very clearly that if I divide it, then you can see this is the plane of symmetry kids. This compound is having the plane of symmetry. Can you see kids? Here is the plane of symmetry. This plane is bisecting this whole compound in two equal parts. Can you see kids? Do let me know. This is bisecting this in two equal parts. So the upper part is exactly like the lower part. So this is your plane of symmetry. So plane of symmetry is present. And when the chiral carbon is also there and plane of symmetry is also there, what you call it, kids? If the plane of symmetry is present along with chiral carbons, then the compound is known as meso. So this is your meso compound, and that's why from where I have started, I've told you that presence of chiral carbon is not the necessary condition, even though it is having chiral carbons, but then also it is optically inactive. Let me show you. I have started with the slide from where I have started. The first slide, kids, that was indicating that chiral carbon is not the necessary condition for a compound to be optically active. So from today, what you are supposed to say that compound should be chiral, whether it is having chiral carbon or it is not having chiral carbon. But if the compound is chiral, then definitely it is going to be optically active. Do let me know. Now, after this, I will tell you one compound which is not having any chiral carbon, but then also it is optically active. Now you will realize that chiral carbon is not necessary condition for a compound to be optically active. And now remember this point that the mirror image of meso will be meso only. Mirror image of meso. Mirror image of meso is also meso, and that is identical. That is identical. So now you must have got one dextro, one levo, one meso. These two are, and this is optically inactive. Why it is optically inactive? Optically inactive due to internal compensation. Optically inactive due to internal compensation. Optically inactive due to internal compensation. Now, kids, I will take your 5 minutes. Let me explain one more where odd number of chiral carbon, and then I will explain one compound which is not having any chiral carbon. Will you give me that much time? Let me sit in front of screen and do let me know, kids, that 5 minutes more. Will you give 5 minutes more, kids? Everyone just do let me know in the chat section and smash the like button if you have not, kids. Till now, if you have not smashed the like button, how many of you are really enjoying this series, kids? Of course, why not? Now, how many of you are really enjoying such great visualization? Everyone just do that in the chat section. Chaitanya is there, Sahana, Priyaji. Thank you, everyone. Thank you. Okay, Sahitya, very good. Mandy. Now, see, so I was telling you this sub case 1 and sub case 2. Now let me reach to sub case 2. When n is equal to odd. So see, these type of compounds, when tough paper is coming, then they can ask. They can give you like this. Or they can give you another example like this. Or they can give you another example like this. Now, kids, what you're supposed to do, because In the examination, there will be no one to tell you that which subcase, which case it belongs, right? So what you're supposed to do in the examination hall, kids, just sit at the center of the compound and go right hand side. Whatever you are getting on the right hand side, just try to see the same thing. Are you getting on the left hand side? Just see exactly the same thing. If you're going right hand side, see there's COOH, there is also being COOH. There is CHOH, there is also CHOH, and this is common. Are you getting my point? From here, if you're going on the right hand side, are you getting the same thing on the left hand side? Yes, of course. See, this is common for both the two sides. So if you go from this side and if you go to this side, are you getting the same thing? That means this is your case. This is your case. Can everyone understand and see how many carbons are there? Now you will find out that this is the first chiral carbon, this is the second one, and this is the third one. First, second, and the third one. First, second, and the third one. But remember, my dear students, this is known as pseudochiral. Known as pseudochiral. 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 Pseudochiral is also known as prochiral. False chiral, right? These two are chiral. This one is chiral, that one is chiral. This is chiral, absolutely chiral, and this is also chiral. Same thing in all the three. Now, how many of you really want to visualize? If you don't want to visualize, you can directly write down two optically active isomers and two meso. 2 and 2, total number of optical isomers is equal to 4. For each case, 4 and 4. 2 plus 2 plus 2. It is also 2 plus 2. It is also 2 plus 2. Now, how many of you really want to visualize? Then do let me know. 1 dextro, 1 levo, 2 meso. I'm sitting in front of screen. Those who really want to visualize it. If left hand side are different, okay, Sahana, see. If left hand side and right hand side is being different, then we will come to this one. Then that will be this one. Case number 1. Here, when no structural representation is having pause case, case number 1, and can be even or odd, doesn't matter. Even or odd. Here it can be even or odd. Then this will be the part of case number 1. Sahana, got it? Got it, Sahana? Do let me know. Okay, okay. Now see. This question has been already asked in AIMS. Same question I'm going to explain. Whether you are applying for AIMS or IIT, it's for you kids. Now see, can you see, is this compound having any plane of symmetry? If you divide it, This side hydrogen, that side OH. There is no plane of symmetry. Can you see everyone? This side hydrogen and that side OH. They are different. So no plane of symmetry and 3 chiral carbons are there. So definitely this compound is declared to be optically active. Right, kids? Suppose if I say this is being dextro, if this is dextro, then it's mirror image, water image. Suppose if I place water over here or the mirror at this place, so this will be known as mirror here and mirror image. So let me copy it H, H, OH, H, OH, OH, COOH, COOH. So these two, if I call them to be X and Y, being X, this is an Y, X and Y are enantiomeric pairs. Am I right? And they are optically active. Definitely enantiomers are being always optically active. Now let's move toward this side and try to see it. OH, OH, OH. Now see kids, this is chiral, but this middle one is not chiral. Not chiral. Why not chiral, kids? There are 3 chiral carbons were present. 1, 2, 3. All 3 were chiral. But here this is not chiral. See why not chiral? Why it's not chiral? See to it. If I draw one line, see, is it bisecting it in 2 equal parts? Can you say there is plane of symmetry present or not? Kids, do let me know. This is the plane of symmetry that is being present or not. So it can't be optically active. Just to let me know in the chat section. So it's not chiral. Now, if I draw OH over here, OH over here, H over here, H, OH, H, COOH. So my dear friends, the upper one, if I say that was X, Y, if I say this is Z, Z, it is having 3 chiral carbons, but then also it is being optically inactive. What's the reason? The reason is internal compensation. It's a meso. It's a meso. Z is being declared as meso and its mirror image will be meso. And this is also meso, but this meso, if I say this is M, this meso is different from that meso. Why, kids? See, all the 3 OH are upside here. 2 OH are being upside, 1 OH is on downside. So see, this is also having a plane of symmetry, even though it is having chiral carbon, but then also it is optically inactive. So this is meso, and this meso is different from that meso. 1 dextro, 1 levo, 2 meso. Everyone got it. After this, I will take 2 minutes only. 2 minutes more after this, kids, just to let me know. Till now, it's everything clear to all of you kids. Each and everything is being clear, kids. Just to let me know, everyone. Yeah, total number of optically active isomers 2 and total number of optical isomers being 4. That's really awesome. 2 plus 2. Let me write down that this thing so that you should not get confused. 2 optically active, 2 meso, so 2 and 2 4 total number of optical isomers. Got it? Now, last but not the least, compound optically active without chiral carbon. Without chiral carbon. So 2 minutes only without chiral carbon. So here is the case of allene. This is the case of allene kids. Allene. Just see. Suppose if I say this hydrogen is coming towards observer side, this methyl is going away from observer. They are horizontal. Suppose if I say they are being horizontal, so definitely if I say one carbon, one more carbon, and it's pi bond. If I draw its pi bond, then pi bond will be going vertically up one lobe. This is second lobe. So second carbon's p orbital will also be going up and down. So they are being vertical. They are being vertical. So it's another pi bond will be horizontal. So it has to be horizontal because it has to form a bond with this. So it is horizontal. So its sigma bond has to go vertical. Sigma bond has to go vertical, kids. Now if I say hydrogen is over here and methyl is at this position, so see, we try to bisect it. We try to bisect it. So if I say the hydrogen, half of the hydrogen coming to with this side, half of the hydrogen going away that side of the board, methyl, 3 hydrogens, one in the plane of board, one towards your side, one away that side. If I go like this, but once I will reach at this point, this side is coming hydrogen and that side is going methyl. So there is no plane of symmetry. If you try to cut it sandwich, it will be able, but once you come over here, upside is hydrogen and downside is methyl, you will never get plane of symmetry. So what the point you have to remember, the point is actual that number of pi bonds should be even, number of pi bonds should be even, and these two valencies should not be same, and they should not be same. They should be different. So this to be even. If it is odd, it will show Gi. If it is even, it will show Oi. Got it? So it is declared to be optically active. This is all for today, kids. How much you have really enjoyed it? You can tell me in the chat section once the video is over. I will definitely wait for your comments. And how was the lecture right now? I want to know. Yeah, everyone, do let me know. Sahana, thank you. Other kids, and do let me know how was this class? You really enjoyed it or not? Any suggestions you want to give me? Then most welcome, my dear students. Priyaji, thank you. You like the slides? Really, did you like the slides? Priyaji, really? Chaitanya, thank you. Thank you, Chaitanya. Thank you, everyone, kids. Thank you, Sahana. Thank you. Thank you. Thank you, everyone, kids. Now, God bless you. Love you, kids. Now, you can share this to everyone, each and everything, whatever I taught you today, really going to help you a lot. Whether you are preparing for IIT or you are preparing for NEET, all the questions will come from here only. All the things which I taught you right now, they are very, very important and they holds a whole lot of weightage, kids, right? Bye, bye. All the best, kids.